Okay, hello. Good evening, guys. This is our March week 3. Okay, happy Tuesday to y'all. Sorry, I started the class a bit late. Something to do just now. Okay, so hey, where's everyone? Why is there only 5 of you today? Hello, Zichen. Is this how I call your name? Is this your first time here? Is this your first time here? By the way, we were in chapter 3. Yeah, I have something I haven't done yet, which is the exercise here. Okay, so guys, before I move on, can you please get your last week's note out first? I want to finish this first before I move on to the next chapter. Okay, I have 2 questions remaining here, 3 questions, sorry. Okay, not first time, have I seen you before? Have I seen you before? Sorry, if I have, then my mistake. Okay, sorry. So many new students lately that I can't get my head straight. Okay, so anyway, number 9. So a bacterium called Staphylococcus pneumoniae is a major cause of serious infection of the lungs called pneumonia. Okay, what is pneumonia? Pneumonia, this is called a lung disease lah. Okay, this is a lung disease. You get this if you have this bacteria in your lungs. Okay, so what do you have to do? You have to take antibiotic. So the graph shows the percentage of cases of pneumonia in which the bacteria were resistant to penicillin. Okay, what is resistant to penicillin? Okay, guys, okay, penicillin is an antibiotic, by the way. All right, you don't use antibiotic for many times, because the more you use them, bacteria one day they will not be scared of them. Okay, so let me put it this way, the more you use an antibiotic, the more they become less useful, the more bacteria is not afraid of them. So as you can see, at 1995, there's only 7% of penicillin resistant. That means when you use penicillin to treat pneumonia, the antibiotic is not useful. 就是这个 antibiotic 它不 work 了，只有7%不 work。OK，那个 bacteria 它已经免疫了，它已经不怕了。OK， so that's the meaning. So from 7%, this thing just keeps increasing, drops back a little bit, but still increasing. So as you can see, the thing is increasing. The thing is increasing. That means there are more and more cases of penicillin resistance, which is not a good thing because you see, maybe right now, okay, right now, like 2023, this thing is like even more resistant cases. Okay, so why is this happening, guys? Why is this happening? This is because of evolution. This is what Darwin said. Remember what Darwin said? Remember what Darwin said? Okay, Darwin said that if in a species, there will be some that can survive, and when they survive, they can pass on to their gene and they make themselves stronger. Remember I said about this moth, when the tree trunks they turn black, the black moth they can survive better, so they will make new baby moths that are black in color, so they survive better in the wild. You guys get what I'm trying to say 明白我的意思哦？这个叫做进化论。你会越进化越厉害，所以你就不怕这个 bacteria 就不怕这个 antibiotic 了咯。Okay, so it's not afraid of antibiotic anymore. So let's go back to here. So by the way, what is an antibiotic? Okay, an antibiotic is a substance that kills bacteria. Okay, 一个会杀死细菌的东西 something that kills bacteria. So describe the trend shown. Trend means how does it look like? Okay, how does it look like? So as you can see here, this thing just increase, right? This thing just increases, right? Okay, so the percentage of cases increases year by year. Okay. Yes, Felice, hello, good evening. We are in last week's notes, question number 9, we haven't finished this. Okay, so this thing will increase year by year. There will be more and more resistant cases. Yeah, it's okay, it's okay. We just started not long. So suggest how natural selection has caused this trend. This is the question they asked. What is natural selection? What is natural selection? That means those that are not scared of this antibiotic, they will survive. Okay, so you can say bacteria resistant to penicillin survive. Okay, that means you don't kill every one of them, you kill maybe 93% of them. So the remaining 7%, they are the strong one. So the next generation, they will make it stronger. So you see, more survive, more survive, more survive. This one will go up and up and up. Okay, so bacteria resistant to penicillin survive. So they will reproduce. Okay, so they reproduce. So the next generation bacteria, okay, will be okay, sorry, I'll change a little bit. Okay, more, excuse me, I phrased it the wrong way, sorry. Okay, more bacteria of the next generation is resistant to penicillin. Okay, that means the next generation, maybe there's 8% now, you see? No, more than that. Now it's like 11%. Okay, just now was 7. Now the next generation, 11% of them are not scared of it. So as you can see, the thing just keeps going up and up and up. The highest we have is like close to 17%. Okay, in like a few years, you go from 7% to 17%. Now 17% of bacteria is not scared of the antibiotic anymore. Okay, it's like the moth story lah. The moth story, you know, the black moth last week we mentioned, like just now I showed the one. When our tree trunks become black, maybe now there's 5% of black moth. So the 5% of black moth, they will survive. And then next generation, next year, you will have 10% of black moth, 15%, 20%. You will slowly have more and more black moth. You get what I'm trying to say, guys? You get what I'm trying to say? Only the strong one will survive and make babies, and the babies will have the same characteristic. Okay, so this is natural selection. This is evolution. Okay, something that is a bit complicated to understand. So what is mutation? What is mutation? Mutation is a change in the gene of an organism. Okay, suddenly your gene change. This is mutation. Okay, suddenly there's a change. This is mutation. Guys, I think my screen is stuck here. Okay, give me a second, guys. My screen is not responding, I guess. Is it okay? So, oh, okay, it's not responding now. Uh, okay, this has to happen like time to time. Okay, I think my connection is not very good today, My connection is not very good today. I'm sorry. So, okay, I think this should be better. Okay, should be better. Okay, sorry about that. Okay, anyway, so next, list 3 factors that cause mutation. What will cause mutation? Okay, first of all, this is natural. You will have natural. You're not sure of the answer for 8E. What's the answer for 8E? Oh, because we didn't do. Okay, we didn't do. Okay, if you want to know, what should Pedro do next? Okay, this is about the strawberry one, I think. The strawberry one. Okay, what should he do next? What should he do next? He should breed the tallest plants again. Okay, breed 2 of the tallest plant again. So you keep breeding them until they become taller and taller and taller. Okay, so you get what I mean, because if you, okay, let's say I have 20 strawberry, I breed the two tallest one, now you make tall babies already, right? Maybe you make 20 taller babies. So I take the two one, I cross them some more, I make them taller some more. This is what we do to make plants taller. Hello Terence, how are you? Okay, we were in last week's stuff. Okay, so natural, mutation is natural. It could be due to radiation. Okay, radiation will cause mutation, just like the Incredible Hulk. So they mutate lah. You know, mutants. Okay, I told you this lah, right? Okay, mutation, radiation, and you can also say carcinogen. Okay, carcinogen. This is not in the notes, but just to let you know. Studying for tomorrow's exam. Wow, we're having exam already. Oh, because it's March already, huh? So what's coming up for tomorrow's exam? Is it gonna include year 7 and year 8? I bet it will, right? Yeah, I bet it will, right? So 3 stuff. So list the advantage and disadvantage of genetically modified crops. 7, 8, 9. Oh, that means everything of 7, 8, 9. 9, not everything, right? You haven't learned everything also, right? So I'm guessing everything of 7 and 8 and 9, maybe the front chapters. Oh, just atoms, I see. Okay. Okay, cool. So what is genetically modified crops? If you remember, this is the crops we do from genetic engineering. Okay, we modify them so that they produce more fruits, better seeds, last longer, more resistant to pesticide, okay, things like that. There I mentioned the answer already. So what is the advantage? So you have higher yield. What does it mean by higher yield? 更多产量. You produce more, right? Maybe when you modify a durian tree, they can give you 20% more durian, higher yield, or you can say more resistant to disease. Okay, they can tahan disease more. They are not easy to get sick. So disadvantage. Okay, this is the advantage. What about this? The disadvantage, what is bad? You might cause allergy. Some people might be allergy to GM crops. You might disrupt balance of nature. Okay, like if this thing is human made, you are making the thing not natural. So maybe in the wild there's no such gene, but you make it there, which is not good lah. Okay, so this is like, extra question lah. This is not in your notes. As I said, this part the GM part and the gene part and the inheritance part is sometimes out of topic, right? Because this is it's a very wide field. It's just like pollution, right? It's just like pollution. They can't just, teach you this much about pollution and you expect to ask you this much, because pollution is a very big topic, right? So 11, this is what we do to our, what is this? Guys, you know what is this? This is our oil pump. You know what is an oil pump? You know oil pump? Okay, hang on, let me close this up. You know what is oil palm? Malaysia is famous for this. Malaysia, we produce a lot of oil palm, just in case you don't know. Okay, we are one of the major exporter of oil palm in the world. All right, so our oil palm, this is what we are planting right now. Okay, we call it Tenera. They come from Piscifera and Dura. Okay, what's the good thing about Piscifera? You see, they have the thick mesocarp, which is what we want. But they have thick shell. Shell is something we don't want, because shell we have to throw it away. And then they have small kernel. This is a bad thing, because we want this kernel to be big, right? Okay, guys, something about oil palm. We use this mesocarp to get cheap oil. Okay, to get cheap palm oil. And the kernel, we use it to get expensive palm oil, right? So if you have a lot of cheap oil, which is good, because oil, you can sell it for money. But you see the expensive oil is very little, very small, so not good. And then you see Dura, Thin mesocarp, this is bad because there's no cheap oil here. Okay, there's no cheap oil here. And then thick shell are something we don't want. Okay, guys, sorry, thin shell is something we want. Because the shell we throw it away. A large kernel, this is a good thing because this is where we get the expensive oil, right? So when we cross this, we get the advantage of both sides. We get the thick mesocarp outside, we get the thick kernel inside, we get very thin shell. We get both of this thick, we get the middle, what we don't want thin. So I get the advantage from both sides. It's like your dad is tall, your mom is good looking, so you are tall and good looking. You get both advantage from both sides. So which makes you good. Okay, you have all the good genes on you. So name the process of getting the Tenera species of oil palm. What is this process called? This is called selective breeding. We have learned this, we have learned this in our notes. Where was it again? It was here. All right, we take two of the good genes, we cross them so that you become better. Okay, so like I said last week, right? You don't want to marry ugly people, right? You want to marry the best looking people you want. Because okay, if let's say you marry someone good looking, your child or your children will be good looking too. That's why we all want our partner to be attractive. Okay, you don't want your boyfriend or your girlfriend to be ugly and dirty. Okay, I'm just being true. Okay, just being true. So name two good qualities of the Tenera. Okay, what is good about this? They have thick mesocarp, they have thick outside, and they have thick kernel, thick inside. And one more thing, they have thin shell. They have the advantages from both sides. I take the advantage from both sides, I make them even better. Okay, guys, cool? Cool. So that's it about chapter 3. That's it about chapter 3. What is the thin shell for? Shell, we throw it away. What? So the thinner the shell, the less wasteful we are. Okay, you get me? So we want thin shell, we don't want thick shell. Of course, the thick shell we don't use one. We just throw it away. Wasted. All right, so that's all. That's all for our chapter 3. I hope you understand this natural selection thing. It's a bit complicated. You will learn more about them in year 11. And year 12, if you choose to go A-levels, you learn more about them. Okay, guys, moving on. Let us move on. Let's go to our chapter 4. Okay, chapter 4. So Terence, you're having your atom exam tomorrow, We are just right into this. Okay, so I hope this helps a little. All right, so guys, we have finished our biology. No more biology. If at the time, maybe I'll repeat, but not before when I go to year 7 and year 8 first. Okay, we'll do revision next time, don't worry. Okay, so this begins our chemistry. So I bet most of you girls hate this, which is very normal. Okay, I know you all hate chemistry, I understand. All right, so let's look at chapter 4, the structure of an atom. I think you learned this in year 7 already, but this is where we learn into details about atoms. Okay, we have so many people we have to talk about, and we have so many atoms we want to talk about. Very interesting chapter. Okay, so a little bit of history time, guys. A little bit of history time. So the idea of atoms. So who started the idea of atoms? Right, it started in ancient Greece. Okay, ancient Greece, which is like close to 3,000 years ago, right? Guys, back then, 3,000 years ago, there were no such thing as science. Okay, science was not a thing. Back then, they call them philosophers. It's philosophy. You know what is philosophy? 哲学. When you think about life, what is the meaning of life? Right? That is philosophy. Right? Because last time, science and philosophy, they belong together. Only a few thousand years later, we split science into science, philosophy into philosophy. So they come from the same root. Guys, when you sit down and think, when you think about, knowledge, when you're thinking about knowledge, that is philosophy. All right. So the teachers of ancient Greece were called philosophers, and from their observations, they generated ideas about almost everything. Okay. So the first guy, he was called Democritus. Okay, Democritus. Okay, it was 460 to 370 BCE. BCE means before Christ. Okay, before Christ. Now we are 2023 CE. CE. That means after when Jesus was born, right? Now it's 2023 years after Jesus was born, right? So 460 was, okay, let me put it this way. This is when Jesus was born. Okay, I put a J here. So this is 2023 CE, and Democritus was born at 460 BCE. So if you go back 2023 plus the 460, so that's a 2483. 2000, around 2500 years ago. All right, so this guy, so he thought about what would happen if you cut something into smaller and smaller pieces until you cannot cut it any smaller, right? So you see, this is how the idea of atom come about. You see, guys, during ancient Greece, there were many great philosophers. All right, until today, we are still using their philosophy. So this Democritus said, what if I take a piece of paper, I cut until it is so small, I cannot cut it anymore? That is what we call atom. You see, so simple, but so smart. We are still, this is how I would still explain to kids about atoms today. This is what he thought about. Something very simple, but yet very smart. Okay, so he concluded that you would come to an indivisible particle. They are so small, you cannot divide them. So damn small, which he called an atom. All right, so the word atom means indivisible. The word atom means cannot divide. That's what he means, right? So he went on to say that atoms of different substances had different sizes and shapes, and that they were able to join together to make even more different substances. You see, he was correct, right? So because according to this, let's say you have hydrogen. Hydrogen is smaller, right? Oxygen is bigger, right? So you see, different sizes. When they come together, when they join, so what happens when one oxygen combines with two hydrogen? You get H2O, right? You get water, right? So this is what he said, right? Guys, 2,500 years ago, there was no technology, there were no books or whatever. He first came out with this idea. So freaking awesome. So this is how it looked like, by the way. Okay, Democritus. So the other philosophers could not agree on the Democritus' creative thought. Okay, so they were saying, nah, you're just bullshitting. They didn't believe in him. So guess who's correct? He was correct, right? And later Aristotle put forward the idea that matter was made from water, air, fire, and earth. This is what Aristotle believed in. You know, Avatar, the last airbender. So this is how it came about lah. So we have water bender, air bender, fire bender, and earth bender. So that's what Aristotle believed in. When we play video games, this is what we play lah, right? We know that fire is good against earth. Okay, fire will kill earth. Earth will kill water, I guess. So sorry, earth will kill air. Was it like this? And then air will kill water, water will kill fire. So it's like a cycle of elements lah. So this is what Aristotle believed in, but of course this is wrong lah. Okay, this is wrong. It's not that way. And this idea was believed to be true until scientists began investigating chemical reactions. Right, so it was 2,000 something years ago. So it was quite long ago. And the next guy who came, it made you an avatar philosopher. Okay, cool. Right, so the next chemist who came, it was 1,000 something years later. His name was Antoine Lavoisier. Okay, Antoine Lavoisier. He's a French guy, by the way. By the way, this name is pronounced as Antoine. He's a French guy. Okay, so something about this guy, right? He was born in a lawyer family. Both his parents and many of his relatives were lawyers, and they are very rich, right? So guys, let me tell you something about Western people. Okay, Western civilization, if you learn about history, Western civilization, they believe that if they come from a rich family, I think I told this last chapter also, they believe that if they come from a rich family, they have a responsibility to do studies to make people's life better, right? Like you see Darwin, you remember Darwin? When he found out about evolution, he actually used his own money and he went to those islands and stayed there for 20 years to study about birds, right? Because last time, philosophers are those people who are very, sorry, not philosophers, people coming from rich family, they feel like it's a responsibility for them to go and discover something, right? Because if they don't do it, no one else could afford to. Because if you think about it, guys, Edison come from a very rich family. That's why he has the money to eat to research about light bulb. Do you think someone poor can do that? No, right? So most of the scientists, guys, uh, Newton came from a very rich family. How else do you think he has money for education, right? If you were poor, you won't even go to school. But you see, Newton, he has a chance to talk about gravity because he was educated in the first place, right? So this is like it's like their way of thinking lah. If I'm rich, I am obligated, I have the responsibility to make humans' life better. So most inventors, most scientists, they come from very rich families. Okay, so was this guy. So Antoine Lavoisier, okay, 1943 to 1743 to 1794. So when he died, he was only 50. All right. Yeah, new fact. Okay, so a French chemist. So he originally was going to be a lawyer, and he was like, you know what? I'm not interested in law. So he went to chemistry instead. So he investigated the changes that took place when two chemicals reacted to form a new compound. So this was what Democritus said, right? Because Democritus said two different sides come together, they will form something new, right? So he went out and do the research. He weighed the chemicals before the reaction, and then he weighed the compound that was formed. Lavoisier found that the total mass of the chemicals was the same as the mass of the compound that was produced, right? What does it mean? That means if he used 5 grams of A and he add this to 5 grams of B, he would get 10 grams of AB. That means nothing is lost. Nothing is lost. Everything will remain their mass. I mean, it makes sense, right? It makes sense, right? You cannot just create atoms out of nowhere. If you have 5 grams of atoms plus another 5 grams of atoms, you have 10 grams of atoms. You cannot create mass. Make sense? Make sense? When you have 5 candies, you add another 5 candies onto it, you don't get 11 because the candies doesn't make another candy. It makes no sense. So this is what Lavoisier, he said. Okay, so from this result and from the result of similar experiments, Lavoisier set out his law of conservation of mass. That means, which states that matter is neither created nor destroyed during a chemical reaction. So you cannot convert charcoal into gold. It doesn't work this way, right? You know, people used to believe they can do this. This is what we call alchemists. Before chemistry became what it is today, it was known as alchemist. You know, there's an anime called Full Metal Alchemist. Anyone? You know the anime called Full Metal Alchemist, guys? If you haven't watched this, I suggest you go check it out. It's a very cool anime. Okay, I watched this many times. Okay, Full Metal Alchemist. No? Yes? Go watch this. This is so good. This is really good. Right? So back then, there was no chemistry. They called themselves alchemists. So there's a little bit of history there. Okay, so this is really cool. Right? So Antoine Lavoisier. Oh, watch already, so you know lah. Okay, so this Antoine Lavoisier, he was known as the father of chemistry. He is the father of chemistry. Okay, because of him, we have modern chemistry nowadays. Okay, so modern chemistry, guys, modern chemistry only started like around 200 years ago. Only around 200 years ago, we have chemistry. You see, so chemistry is like a very new field. Can you see this? That's why, guys, science is something very new. Okay, if you go back 100 years ago, nobody studied science because science is something that people cannot understand. But now you see, 100 years later, science is like a basic subject that even a kid has to study. I'm sure your primary school brother is already studying science. So science is something that is very accessible to everyone. Okay, everyone can study science. Okay, so next guy. Okay, the next guy, like around a few years later, this guy called John Dalton. He is the first guy who discovered atom. So John Dalton was an English chemist who studied gases by combining carbon and oxygen. Okay, so when he combined them, he found carbon dioxide. So the first of them seemed to be made from one particle of carbon joining with one particle of oxygen. One particle of carbon joining with one particle of oxygen, you get carbon monoxide, CO. And in the second gas, it seems that one particle of carbon joined with two particles of oxygen, you get CO2, right? So Dalton put together his atomic theory. He suggests that, okay, from this, you see, this experiment is really simple, but he came out with this. All matter is composed of tiny particles called atoms, right? So he continued what Democritus said. Atoms cannot be divided up into smaller particles and cannot be destroyed. That means if this is a carbon atom, this is like a carbon ball, you cannot split this smaller. There's no such thing as half carbon. It's like Lego. It's like Lego. You see, you have when you have two pieces of Lego, you take them apart. The simplest piece of Lego, can you chop it smaller? No, you can't. No, you can't. That's the simple thing. The smallest Lego is the simplest already. So again, this is what Democritus said. Atoms of an element all have the same mass and property. Okay, that means all carbon, they are all the same. They all have the same mass, they all look the same. The atoms of different elements have different masses and different properties. So carbon and hydrogen, they look different. They have different weight, different mass. You see, simple, right? So number 5, atoms combine in simple whole number when they form compound. What does it mean? You have CO, you have CO2, you have CO3. There's no such thing as CO 1.5. How can you have 1.5 of O? O is like a Lego. You can either have one piece of Lego or two pieces of Lego or three pieces of Lego. There's no such thing as half a piece of Lego. You cannot chop it into half, right? So this was what Dalton said. Guys, it's not very long ago, guys. It's only like less than 100 years, okay, more than 100 years ago, like 100 something years ago, Dalton said this. Okay, and according to Dalton, atoms look like this. This was Dalton's model, right? Can you see? This is called a billiard ball model. You know, it's billiard. Billiard is snooker lah. Okay, billiard is your snooker lah. There, you know snooker. So according to Dalton, atoms look like this. It's like a round ball. But of course, now that we know that atom doesn't look like this lah, but this was like, guys, 100 something years ago, right? 100 something years ago. And then next guy, okay, wow, guys, I'm teaching history now, isn't it? Okay, guys, all these it's not coming out for exam. I'm just telling you for fun, okay? This thing will be coming out in your year 10 chemistry. Year 10 chemistry, so you still have to know that. Okay, so next guy, he is Joseph Thomson, sorry. Joseph Thomson. I just call him JJ Thomson because his name is JJ Thomson, right? So during the 19th century, great developments were made in the study of electricity. Now 19th century electricity came, and the development of electric apparatus for use in investigation. So now they're starting to use so guys, when electricity came, our scientific improvement just improved very quickly, right? They just improved very quickly. So one of these piece of apparatus was the cathode ray tube. What is this? Cathode ray tube. This was what J.J. Thomson used. This thing. This is a cathode ray tube. Guys, you know where we use this? We use this in our old TV. You know these TV, the one that big, like don't know what one. When I was a kid, this was my TV, right? I grew up in the 90s using this TV. All right, so inside there's something called cathode ray tube lah. Okay, so Thomson used this to study atom, right? So Joseph J. Thomson, okay, let's just call him J.J. Thomson. So J.J. Thomson investigated these rays and discovered that they were made of tiny particles, okay? So he discovered atoms also. And Thomson called the particles corpuscles, corpuscles. This is how I say it, okay? Corpuscles. But George Stoney, an Irish physician, named them electrons. So Thomson was the guy who found out electrons. Okay, he said that atom has all this negative charge on it, and these negative charges they are particles too. So this was his model. All right, this was his model. Okay, so in 1904, Thomson devised a model of the structure of the atom from his study on electrons. He proposed that electrons were present in the atoms. Guys, you have to know, these people, they have never seen atoms before. They have never seen atoms before. What they were doing, they were trying to guess. So when Dalton was guessing, he guessed that atoms look like this. And then when Thomson did experiment, he said what? So Thomson said, no, actually this is wrong. Dalton's model is actually wrong because according to Thomson, Thomson said, where's the negative charge? There's no negative charge here, so this is wrong. So according to him, your atom, it looks like this. According to him, this is his model. So according to him, atom is like one ball with all the negative small balls on it. Okay, it's like one big ball with all the small balls sticking at the side. So this was his model, right? Of course, we know this is wrong, but this was his best guess, right? So he knew that electrons were negatively charged and it must be balanced by a positive substance in the atom. He described the atom as being like a plum pudding with the negatively charged electrons being surrounded by a positively charged pudding. Okay, I want you to think of this as, you know what's a raisin cupcake? You know what's a raisin cupcake? You imagine this is the cupcake and you have all these raisins on it. The raisins are the negative charge, right? But according to Thomson, he said, if you have, let's say, 8 negative charge, you must have 8 positive charge to balance it, right? You cannot have 1 negative and 2 positive or 3 positive with 2 negative. It must be balanced, right? So according to him, this 8 should be balanced. When I have 8 electrons, I must have 8 positive. That time there was no proton yet. You know it's proton? Proton is the positive, right? I mean, you guys learned it before. But that time, there was no such thing as proton. So he just called them positive charge. Okay, he just called it positive charge. Okay, so this was his model. Okay, this was his model. Okay, now comes another guy. Okay, now comes another guy. His name was Ernest Rutherford. Okay, his name was Ernest Rutherford. He was a very smart guy. So he spent time studying radioactive materials and discovered that there are 3 types of radiation: alpha particles, beta particles, and gamma rays. You know what are these, guys? You know what are these? You know what are these? These are radioactive radiation. Alpha, beta, and gamma, they will give you cancer. Oh, you heard before gamma, huh? Okay, alpha and beta is the same thing. So guys, if today, you know where is Chernobyl? You know where is Chernobyl? This was when the Chernobyl disaster happened. Now this town is an empty town. It's an empty town. It's been empty since 1986, I think. Because of a nuclear power plant, not because of a bomb, because of a power plant. Okay, they used to use this place to generate electricity, so the thing failed. So if you walk inside here, today, you will get a lot of alpha, beta, and gamma radiation. Okay, so can you go inside here? Yes, you can, but only for a few hours. So guys, if next time you want to go somewhere special, go what Thailand lah, go what Taiwan lah, you want to go somewhere special, you go Chernobyl. You are allowed to enter for a few hours before you get too much radiation, so you have to come out. Yes, gamma is the thing that turns Bruce Banner into the Hulk, yes. But gamma won't turn you into a Hulk. Gamma will give you cancer. So no. Right? So this is your alpha, beta, gamma. So Rutherford was playing with these 3, and Rutherford had found that alpha particles were large, positively charged particles, much larger than electrons, and decided to use them to test Thomson's idea about the plum pudding. Right, so you see, Why Vin Diesel? No, you won't. Right. Okay, so you see, Thomson's model is the plum pudding model, isn't it? So according to Rutherford, since at okay, this is a plum pudding, right? If I use a ray and shoot here, okay, what happens if you use a ball and you shoot at a cupcake? The ball cannot go through, right? The ball cannot go through, right? Because pudding is like, okay, if this is one pudding, okay, I don't know how to draw pudding lah. If I shoot a ball here, do you think the ball can go through? Cannot, right? Because the pudding will block it, right? But now you see, when Rutherford did this experiment, something funny happened. All right, so Rutherford's plan was to hang up a thin sheet of gold. So he put a sheet of, this is Rutherford's experiment. So he put a sheet of gold here and then fire alpha particles at the sheet, and the alpha particle will eventually hit the screen and be detected. So when he put alpha through, when he shoot the ball through the pudding, he found something funny. The ball went through. The ball went through. Like 99% of the ball went through. So according to Rutherford, so you know what Rutherford said? Rutherford said, since if Thomson is correct, if Thomson's model is correct, how can the ball go through? You see how smart he was? Right? He said if the ball can go through, that means this is not a pudding. This is an empty space. Atom is 99% of alpha can go through because 99% of atom is empty space. Right? You see, I shoot my particle through. You see everything can go through, right? The 1% will hit the nucleus, cannot pass through. That means Rutherford's model is the model we are using today. Okay, of course, the Bohr made it better, but Rutherford is the one that we are using, the one that looks the most like it. So this was what he said, right? You see, can you see all these gold atoms? Why can all the alpha pass through? Because it's all empty space. Can you see all these are empty space? The alpha can fly straight through. So Rutherford was a very smart guy, right? So Rutherford predicted that if Thomson's model was correct, if this plum pudding is correct, all the alpha particle would pass straight through the gold atoms and make a mark and hit behind the gold sheet, right? I mean, couldn't pass through, sorry. Most of the alpha particle made a mark directly behind the metal sheet, the thing can go straight through, but some made marks all around the screen. This did not fit in with the prediction and suggests that the atoms had a structure that was not like the plum pudding. So according to him, why will some be reflected? Why will some go through here? Because most of it is empty space. Most of it is empty space. And since alpha is positive, right? This is a bit high class chemistry already. Since alpha is positive, right? If I go near the nucleus, which the nucleus is also positive, positive and positive, they will reject, right? You learn this in primary school. Same charge will repel. So positive will repel. So this alpha will bend. Okay. And if I hit this further straight, I will bounce back. So according to Rutherford, this is the model that makes the most sense, right? Which is correct. So we are using Rutherford's model right now. So according to him, according to Rutherford, you have electrons spinning around. All these are electrons, and you have a very heavy positive charge in the middle. So he's correct, right? He was correct. You see how smart. That's why Rutherford got Nobel Prize. Rutherford got a Nobel Prize. Guys, all these people, guys, all these people, they are freaking smart. You know that? They are freaking smart. That's why they got Nobel Prize. Okay. So anyway, so Rutherford reasoned that as some alpha particle appear all over the screen, they must be hitting and bouncing off something inside the atoms that repel them. So he knows that something is repelling them. As most pass through, there must be a large amount of empty space in an atom to let the alpha particle pass through. See, a lot of empty space. That's why alpha can pass through. Right? After further thought, Rutherford concluded that an atom did not have a positively charged pudding around the outside, but instead had a positively charged center or nucleus, which was surrounded by negatively charged electron. This was his model. Okay. Funny when I mentioned pudding because pudding is my dog. Okay. Pudding is my poodle. my poodle is called Pudding, so it feels I'm calling her every time. Okay, my it's a girl lah. My Pudding is a very sweet girl. Okay, she's very playful all the time. Okay, anyway, so next was Bohr. Next was Bohr. Okay, I didn't mention here, but Bohr. Okay, you know who is Bohr? Bohr said okay, according to Bohr, electrons they don't go around like this. They go around in shells. I wish you will learn this in chemistry. First shell you can put 2 electron. Second shell you can put 8. Third shell you can put 8. This was what Bohr said. Okay, hey guys, Bohr tell you something Bohr is a very good friend with Einstein. Okay, you see, they hang out all the time. They are good friends, Einstein and Bohr, right? You see, two of the most brilliant mind hanging out. Okay, you know what's the Solvay conference? Let me show you something. Solvay conference. Okay, there was a year in 1911, all the best physicists in the world, people who study physics, all the best physicists in the world, they gather in this thing called the Solvay conference, and they all sit together. Can you see who's in the middle? Okay, let me show you something, the Solvay conference with the names. Solvay conference with names. Okay, let me show you this. Okay, yeah. You see who's in the middle? Yes, it's Einstein. All right, and can you see 2 places to the right of Einstein? Okay, your left. You see 2 spaces left to Einstein. Can you see a woman there? She's the only woman there. You know who is she? You know who is she? Anyone? Who is the woman sitting there? There's only one woman sitting at the first row. Okay. Third, if you count from the left. Yeah, who is she? Do you know who is she? I think you have heard her before. Her name is Marie Curie. Yes, Marie Soloska-Curie. Yes. Guys, I have to talk about this woman. I have to talk about her. She is the only person, she's the only person who got 2 Nobel Prize. 2. It's hard enough to get 1, she has 2. The only woman and the only person who has 2. She has a Nobel Prize in physics and she has a Nobel Prize in chemistry. Freaking awesome. She's freaking awesome. Okay, so okay, by the way, guys, what she discovered, she discovered something called polonium. Okay, polonium. This is a radioactive material. Okay, radioactive material. Please don't touch this. Please don't touch this. This thing will kill you in a very short time because it's very radioactive. So Marie Curie, okay, she also handled this thing called radium, also another radioactive material. She handled it with her hands. Okay, Marie Curie handled, she hold radium and polonium with her hands. That's why Marie Curie died because of, I think it was leukemia, because of too much radiation. Okay, so if you go to the Curie Institute, okay, guys, this was Marie Curie's lab. This was Marie Curie's office. And you know what's the amazing thing? You know what's the amazing thing? The door handle in her office, until today, it's still radioactive. You know why? Because after she played with the radium and the polonium, she will use her hand, the radioactive hand, she will hold the door handle, and now the door handle has radiation. Even until today, the radiation is still there. Right? Yeah, she didn't know it was radioactive. Guys, we didn't know what radioactive was until the atom bombs came around. Right? So you see, during that time, like 1920 something, 1930 something, it was the age of discovery when we first discovered atoms, when we first discovered atom bombs. You know what's the Manhattan Project, guys? If you're interested, okay, guys, if you have the time, go and read more about these things. Manhattan Project. This was the project started by the US government to make atom bombs. You know the two bombs dropped in Japan, Nagasaki and Hiroshima? It's started by the Manhattan Project. Right? Go and read more about this. US, they have atom bombs because of this project. It was a top secret Asian project. It's a top secret project by the US government, the Manhattan Project. Really, really cool. Okay, go and read about this. Okay, anyway, so Marie Curie, pay attention to her. Pay attention to her. She's freaking awesome. She's freaking awesome. Who have you heard won 2 Nobel Prize? No one. Okay, so, hey, and guys, you have to know this. She won this in around in the earlier 20th century, like around 1911, like that, around there. Guys, during that time, women have no rights to go for education. You know this, right? You know this, right? Not many girls get to go to school that time. Not only she went to school, she got 2 Nobel Prize. You really have to respect her, right? And she carried out the research with her husband, I think. Okay, she carried the research with her husband, carry out the research with her husband. Okay, so they both work together. Freaking awesome, guys. Two. Okay, that's never heard before. Right. Anyway, so this was what happened when atoms are. So guys, can you see all these chemists they're like building a pyramid. Okay, so you start from Democritus, then you have Antoine Lavoisier, you have John Dalton, J.J. Thomson, Ernest Rutherford, Niels Bohr, and we have other people as well. We have Einstein, we have Marie Curie. So the pyramid that we are enjoying today, the pyramid of achievement, it is done because of these people, right? They all contributed to their part. Only we have our technology today. You get what I'm trying to say here? You get what I'm trying to say here? So what we are having right now, the technology we are having right now, it is because of contributions from our past ancestors. That's why if you ask me, sir, why do I have to study about them? Why do I need to know about them? Guys, to study history is to respect people who came before you. Is to respect technology. Is to respect the effort they went through to let us know what was not known. Right? You think what was the name again? You think sorry, Charles Darwin. You think Charles Darwin, he pay his own pay his own money, use his own ship to go to the island to study birds for nothing? Hey guys, without him, we wouldn't know about evolution. Right? Yeah, although he's dead today. So guys, I always hate people who say, sir, I study history for what leh? I study history for what? We study history, number one, to pay respect to these people, and number two, to not repeat their mistakes. Right? You know what Herodotus said? You know who is Herodotus? The father of history. The father of history. Okay, you know what he said? Those who, wait, did he say that? I forgot already. Okay, those who did who don't learn history. Oh, sorry, Winston Churchill. Okay, I think this thing originated from Herodotus, if I'm not mistaken. Okay, those that fail to learn from history are doomed to repeat it. If you do not learn history, you will repeat mistake made by past people. Okay, so guys, I'm a very big fan of history. I'm a very big fan of history. Yes, past prime minister. Oh wow, you know that? Okay, he was the prime minister during World War II. Very iconic person. Right. Anyway, so you know, I'll leave this to your history teacher lah. I don't want to talk about too much about history. I'm a very big history geek. I can spend 3 hours talking to you about World War II. Anyway, so moving on. So the structure of atom. Okay, so this is what atom looks like. Okay, so this was what Rutherford and Bohr said. You have an electron circling around. You have neutron and proton in the middle. And this is called your nucleus. Remember? Remember this? You learned this in year 7 actually. So the word atom comes from a Greek word that means cannot be split. You cannot split atom. I mean, we can. This is what we call atom energy. You know what is an atom bomb? You know what's a nuclear bomb? That is when we split atom. But you know, that's another topic already. So it is made of subatomic particles. Okay, subatomic means inside the atom. So inside the atom, we have three things. We have proton, which is positive. We have neutron, which is neutral. And we have electron, which is negative. Okay, so this guy is like, here. Okay, so you know what, guys? I'm going to stop here. But next week, we'll talk about the periodic table. Guys, this was what Antoine Lavoisier said. You know, the father of chemistry, Antoine Lavoisier, his periodic table used to look like this. Okay, and you know what he put inside? He even put caloric inside. Caloric. You know what is caloric? Calorie. He used to believe that calorie is part of an element, right? I think he even put light inside. I think this is Lumiere. He even put light inside the periodic table. But then we know light is not an element. Light is an energy, right? But this was what how his, if you take time machine back to 200 years ago, periodic table used to look like this. Okay, not like what we have today. You see, now our periodic table looks beautiful, absolutely beautiful. Okay, but this was then next week I'll talk about this genius. His name is Dmitry Mendeleev. He's the guy who contributed a lot to this periodic table. Wow, guys, I can talk all day about this. I'm a big chemistry geek. Okay, anyway, guys, you know what? I think I'm going to stop here. So I hope you learned something new today. So this is more like a history lesson for you. So next week we shall go jump straight to the main topic, huh? Okay, so any of guys here have any question? Do you have any question? If there's no question, then I will be seeing you next week lah. Okay, so have a good Tuesday night, guys. I will see you soon, the same time next Tuesday. So have a good one. I will see you soon. All right, so take care, guys. See you. Good luck in exam, parents. I'll see you to next week. So see you. Take care. Bye bye. Okay, bye, guys.